Thank you very much for the introduction. I'm honored to be a part of this webinar today. And I would like to talk about evaporative cooling equipment. As the name indicates, it is cooling, but there are also other functions of evaporative cooling and it can be a very useful tool fighting against COVID-19. Many of you may not even think about it. With the global pandemic going around the world, it is important for all of us to think how we can fight against this pandemic. So I'm going to talk about evaporative cooling aspect of it, as well as how the evaporative cooling equipment can affect our health. So it is a current topic. I'm hoping you are all interested in learning more about it. I have been doing research in this area, not COVID-19, but evaporative cooling and health area for a number of years. So when we look at evaporative cooling, okay, evaporative cooling actually, history of evaporative cooling goes back thousands of years. When you think about it, all the way back to ancient Egypt and Persia and even Greece and Turkey, many of these old ancient establishments had water features. They used it to cool their spaces. And in some of the ancient civilization or towns, places I've seen, they ran water under the streets to cool the streets and the ambient. So it is a very historic evaporative cooling. So it makes the HVAC industry history going back thousands of years. This historic cooling method is still being very popular in modern days. As a matter of fact, it is becoming more and more popular. Now it is considered as an eco-friendly cooling method used for process and comfort cooling. I'm going to get into the details of process and comfort cooling in this presentation. And evaporative cooling can be achieved in many ways. Some of you have seen misting stations and some other media type. We'll all get into these and we'll have a deeper dive. It's very effective for space humidification and provides health benefits, and we'll talk about how it can help fighting COVID-19, as well as not just COVID-19, but all other influenza-based viruses. Evaporative cooling works better in drier climates where the cooler, more humid air is desired. But of course, some of you may say in drier climates, it is very difficult to find water. There are research in evaporative cooling area to use gray water. And many companies are trying to certify their evaporative medias for that purposes. Okay, evaporative cooling can be achieved in different ways. It can be direct or indirect cooling. I worked for 4 different companies in my career that had evaporative coolers, evaporative cooling equipment, provided cooling for different applications. And in my past, I've used all these technologies. The most common and known are the wetted media, or a media that it looks like corrugated cardboard, and you soak it with water, with the water distributor on top. You drip water and the hot air enters. You move the air using a fan, and cool fresh air comes out from the other side, typically at a very high relative humidity ratios. And excess water is collected at the bottom. Sometimes it is recirculated, sometimes drained to control the mineral content. The other direct evaporative cooling, as many of you know, the misting stations. These are very simple technology. It can be low pressure or high pressure. And also indirect evaporative coolers. These are for mainly process air coolings. In my past career, I've used indirect evaporative coolers for data center cooling purposes to control the humidity ratio in the data centers or even just the process air. So when we look at around, we will see many ways of these evaporative indirect and indirect versions can be used. Indirect evaporative coolings in the United States, these are very popular, portable coolers, and also event coolers. Portable coolers have one fan and evaporative media on the other side. It is one directional. There are also event coolers, pulls air from all four sides. The fan blows it from top into an event. It can be ducted or just freely blowing into the space. All you need is water and electricity. The air coolers typically goes into air handling units. These can be made with stainless steel housings and number of stages. In here you can see two stage, 1 and 2, 33% and 66% to control capacity, actually more than just 2 stage. Actually it can be 3 stage, 33%, 66% and 100% range. So this type of equipment can give us a very wide range of cooling capacities. It can be used for cooling towers and misting stations and wet walls. The wet walls are mainly used for agricultural and horticultural applications, for greenhouses as well as the animal barns. In this presentation, I'm going to talk very little about cooling towers, but I'm trying to focus on usually comfort cooling side of it, because we are going to talk about the COVID-19 aspect of it. As I mentioned, evaporative cooling applications, the airflow ranges can be very large, from small comfort cooling, 2 to 9 cubic meters per second, to all the way to large data centers or power plants. Airflow capacities can go up to 1,650 cubic meters per second. This is very large. This can be achieved by bank, we call it the evaporative cooling banks to achieve, and they can be stacked side by side or on top of each other. In the United States and other parts of the world, these are usually used for power plant inlet coolings. As you can see here, very large airflows, and cools the inlet air of the turbine engine and significantly improve the efficiency of these turbine engines. In the past, I've worked with turbine engine manufacturers to cool these type of equipment, very exciting large equipment. So the application is very wide. It can be used in small room to power plants. So earlier on, I mentioned about the difference of direct evaporative cooling for comfort versus cooling towers. I just want to briefly mention it here, even though I'm not going to get into the details of cooling towers. But there's a big difference, even though in theory, they operate very much the same. Direct evaporative coolers have the same issues to address as those in the cooling towers, water fields. However, the operation of direct evaporative cooling is significantly different than the cooling towers. The theory is the same, but operation is very different. Cooling tower water treatment is intended to protect the heat exchangers, which is always submerged, as you know. And cooling tower media is constantly wetted with more than average 15 times the water loading of direct evaporative coolers. What do I mean with this is with direct evaporative coolers, the wetted media needs to be dried every so often. Most people try to dry the media once a day to prevent algae and bacteria growth. Because the use of chemicals are restricted, at least in the United States and some other countries, what kind of chemicals can be used is very different. Cooling towers can use chemicals that is not allowed in the buildings. Therefore, cooling tower media can be made out of plastics and metals because they can resist to chemicals, as opposed to the media used in direct evaporative media. Direct evaporative media is very porous and holds more water, and as I mentioned, the chemicals. So when we look at the comfort cooling side of it, you can see a typical application here. You may have seen this. You can have a return air, you can exhaust it, a simple air handling unit. Using 35 kilogram an hour water and 1 kilowatt of electricity, this is just hypothetical numbers, we can achieve approximately 24 kilowatt an hour cooling. I converted these from BTUs, so there may be some rounding errors, but this is approximately 8.5 kilowatt of electric savings. So using 1 kilowatt electric and 35 kilograms of an hour water, we can achieve significant electric savings in an example of 10,000 cubic meters an hour air supply. As you can see, the air enters at 35 degrees at 30% relative humidity. After the misting stations, evaporative cooling, it can go down to 26.6 degrees at 60% relative humidity. Sometimes designers can add heating coils. Either it can be condenser or just a direct heating, and then DX cooling coil can also be added here. To improve the efficiency, we can also add a heat exchanger here. In this case, 35 degree air, 40 degrees entering in, and conditioned air goes in at 25 degrees, and then same air can be returned back and cooled. Since there is no humidity exchange here, moisture exchange, this cooling is directly the temperature change. The moisture is not added in here. So these are typical applications. In this example, this is a larger unit using 100 kilogram an hour water and 31,000 cubic meter an hour unit. Our savings can be 15 kilowatts of electric savings. So these units can scale up and down. And as we scale it up, savings significantly improve. In this example, I picked, we have a heat recovery wheel efficiency of 58%. Okay, I just want to briefly touch this topic before I start talking about the other benefit of evaporative cooling, which adds humidity into the air. So, as I said, evaporative cooling units, we all know they cool and add humidity as opposed to just DX cooling. In DX cooling, we cool the air but remove the moisture from the air. Here, I just want to go over some basics of the humidity. What is humidity and how do we measure it? As you know, the humidity is the amount of water in the air. We measure it either absolute or relative. Absolute humidity is the mass of water in particular volume air and expressed as a mass, either grams and kilograms of air, dry air, of course. And the relative humidity is the amount of water in the air relative to how much it can hold given the temperature. These are basics. I'm sure many of you already know this, but I added this in case some of the members may not be experienced in psychrometric tables or the humidity basics. So how does humidity affect our health? That's the side benefit of evaporative cooling. So ASHRAE, Technical Committee 5.7 and other ASHRAE committees, they started a preliminary research in 1960s with a focus on allergies. The Sterling chart was first published in 1985 after a couple decades of research. And it was focused on allergens and pathogens and chemicals. As you can see here, when the relative humidity is very low, bacteria, virus, respiratory infections, allergies, and ozone production significantly increase. As the relative humidity increase, the side effects of these health factors start diminishing. On the other hand, after a certain level, approximately 60% relative humidity, some of those negative effects come back. In addition to mites, these are dust mites growth, and chemical interactions can increase. So ASHRAE recommends keeping the relative humidity in occupied spaces to be somewhere from 30 to 60%. And this was updated by ASHRAE a number of times. And few years ago, ASHRAE Committee 5.11 and 5.7 together sponsored an ASHRAE research to expand the benefits of this humidity and Sterling chart. And that was published, I believe, 3 years ago. And that was also sponsored by several other institutions, such as Mayo Clinic in the United States. So what happens when the humidity is low or very high? Membranes, our nose, dry out when the relative humidity start getting lower, at the low humidity. Why am I talking about that? I'll get into that in a little bit. Humidity above 30% RH is needed for mucous membranes in the nose to properly filter the air we breathe, because that is an important defense mechanism our body has. Okay, viruses like SARS-CoV-2 that causes COVID-19 pandemic can easily pass through nasal passages and accumulate in our lungs. Because viruses tend to attract moisture to survive. We'll get into that in a little bit more in depth, okay? This becomes more significant in elderly population. As you know, with the global pandemic, the first group of people were affected with the pandemic were, the elderly people at nursing homes, and our loved ones were impacted with that. So I'll get into the little bit more details of this. So also, in addition to our mucous membranes, our lungs are very moist, and low humidity result in breathing smaller particles. And we are more receptive to receive these viruses in large quantities. Low humidity can increase the creation of these exhaled viruses, and it creates greater likelihood. Okay, so how does that affect? Okay, in recent humidification research, that is one of the research study TC511 and TC57 sponsored, improve some of these graphs. Studies show that higher humidity reduces infection of influenza. And we believe SARS-CoV-2 virus is distribution is very similar. Currently, I'm in the process of writing RTAR, we call it, Research for Technical Evaluation, is being written to validate and verify how evaporative coolings can help reduce influenza, either capture or maybe have some negative effects. There can be some negative effects. We can also take a look at it, but there are more positive effects. And how to prevent those negative effects, I'll get into it. So, mechanism of infections. Okay, what happens, as I mentioned earlier, viruses are attracted to moisture. When we sneeze, cough, a virus such as influenza virus causes we call common cold, or COVID-19 or other bacteria, they need moisture in the air to survive. So they are attached to the moisture. If the air is very dry, air absorbs the moisture from the bacteria, and bacteria, the moisture gets separated from the bacteria, and bacteria start shrinking, but they don't lose their DNA and become suspended in the air. The smaller they are, they can float in the air as many as 41 hours, a smaller virus. So if there's no moisture. If there is more moisture in it, it becomes heavier and it settles to the ground and travels less. So with a low relative humidity, approximately 10%, this virus or influenza can suspend in the air 41 hours, travel 10, 15, 20 meters, and infect so many more people. If it is heavier, it will fall to the ground. So if the fresh air is used, evaporative coolers with immediate can scrub some of these particles from the air and adds humidity into the airstream, so it is good for our health. But the negative effect I was mentioning earlier, there are some theories bacteria and mold and mildew can grow in drain pans. So it is very important to treat the drain pan either using UV lights or drain them regularly. If the water is not treated, also Legionnaire disease may develop. So we need to be very careful. We don't want to turn something very beneficial into health disadvantage. Okay, so going back to the graphs again, pictures, just to make it a little bit more visual. These units needs to be used properly, okay? The question was raised a year ago by a number of people, does evaporative coolers distribute SARS-CoV-2 virus? So They do not distribute as far as the research has shown so far, but the question still remains, will the virus will enter and spread into the space? So there's two schools of thought right now that needs to be researched, and that's what the research projects topic I'm writing is. One theory, the surface of the wet surface will capture and collect it in the drain pan. But that needs to be drained every so often, so it is not going back into the space. This question still remains unanswered at this moment, as far as I know. There may be some research. If there is one, I would like to know, because we can definitely merge it with our research in the United States. Since the pandemic started, United States Center for Disease Control recommended increased ventilation rates in all closed spaces. Also recommended increasing the humidity levels. But many manufacturers are making claims about COVID-19 related issues, and most of the claims are not accurate. They are not supported by scientific evidence, and the purpose of our committee to make sure we can support these claims or questions through the scientific research. I've talked about some of the questions. A similar question was also dock-mounted evaporative coolers. Some claims, as I said, may scrub the air. I talked about this. So what do we do about this? Okay. When the evaporative cooling equipment, either via misting or wetted media, maintenance is more important than ever. We need to make sure there is no bacteria, mold, mildew, or COVID-19 growth within the drain pans. We know bacteria, mold, and mildew can grow, but we are not sure about the COVID growth. I've contacted a few research facilities in the United States. So far in the United States, COVID growth testing is controlled by government. Government does not want everyone to do research and increase the distribution of COVID. So we are still working with universities. When you use your evaporative coolings, water needs to be treated not just for bacteria, also the Legionnaire disease. And we are recommending periodic drains. And UV light treatment is also recommended. Oh, sorry, my light is going dim here. And some companies offer ionization type air sanitizers on the air side. Sorry, my lights just went off here. So that concludes my presentation.